All right. We have gone over 2 different numbering systems, and we've learned how to convert, we've learned how to add and subtract. But remember us saying that every character equals 8 bits? When the computer is doing math, it strips off what's called a zone. So we've not been working with 8 bits, have we? Mm-hmm. But in the computer, every key you hit becomes 8 bits. So if everything, every letter, every number, every special character is a series of ones and zeros, how does it know that this set of ones and zeros is a number and this set of ones and zeros is a letter?
Through a conversion table.
Okay, we've got to have a scheme, a coding scheme, a conversion table that lets it know this is what these are. So we're going to start with Ascii. Stands for Extended Binary Coded Decimal Interchange Code. All you need to remember is Ascii. This is used on the mini computers, the mainframes, the supercomputers, the larger ones that are used in most businesses. We've got one here. There is an 8-bit code. In Ascii, well, before we go there, what is this called? This right here. A bit.
Oh.
What is this called? That's the byte. What is this called? Oops, too far.
Nibble.
That's right. A nibble. I'm serious. Sounds like you're having lunch. Kind of makes me hungry. So the smallest unit in the computer is a bit. Every character is made up of 2 nibbles to make a byte. Let me get rid of all of this under there. In Ascii, the 8 bits are divided up into 2 sections. They split it right down the middle, and it's divided up. The left 4 bits are referred to as the zone. The right 4 bits are the digit. In Ascii, all numbers have a zone 1, 1, 1, 1. All of them. Every number has a zone of 1, 1, 1, 1. So if I ask you to give me Ascii for the number 6, what are these 4 going to be? 1, 1, 1, 1. And now we're using binary again, so we go back to our binary number line. 1, 2, 4, 8. But because it's divided up into 2 sections, we start over. So you've got 1, 2, 4, 8 on the digit, 1, 2, 4, 8 on the zone. All right, now looking at this, how can I get the number 6?
0, 1, 1, 0.
4 plus 2 is equal to 6, isn't it? So you hit the 6 key on the keyboard, and this is what happens in the memory of the computer. The computer sees these 4 and it says, this is a number. When it sees those first 4 bits, it knows that's a numeric character. All right, what if I ask you to give me the Ascii for 3, the number 3?
1, 1, 1, 1.
1, 1, 1, 1.
0, 0, 1, 1.
1, 1. Does everybody see what we're doing?
No.
No. Okay. This is a given.
I don't see how that 3 is that.
Okay, look at these numbers. 2, 4, 8. Your number line, 2 plus 1 is equal to 3, right? And up here, 4 plus 2 was equal to 6. So you take the last 4 bits and you make the number equal
Where do
to
you get those 4 ones in the front?
Okay, these are the zone. In Ipsidic, that's a given. All numbers have the first 4 bits of 1, 1, 1, 1.
Okay.
Okay?
Yeah.
Everybody all right? All right. Now, before you do something, think about this. How many keys did you have to hit to get 25 into the computer? You hit 2 separate keys, didn't you? So you've got to divide this up and do 8 bits for this and 8 bits for that. So the first one would be 1, 1, 1, 1, and then do the 2, 0, 0, 1, 0, and then 1, 1, 1, 1, and we've got to do a 5, which would be 0, 1, 0, 1. You hit 2 keys, and that happened. Now do you begin to see why everything takes so much room in the computer?
You have to start over with the Ipsidic too.
Yeah, you start over with the zone. You got to have a zone and a digit here and a zone and a digit there because you've got to have 8 bits. Is everybody with me?
Yeah, no need for all this making food.
No need for it, huh? Does anybody have any questions about numbers and Ipsidic? If I gave you a 5-digit number, which I'm not, but if I did, what would you do?
You just keep it up.
You divide it up into 5 individual bits, put 8, so you'd have, what's 5 times 8? 48? You'd have 48 ones and zeros.
8 times 5?
That's 40.
40, okay.
So you're lining. That's
Yeah.
how you're supposed to write it down.
Yeah. Now, if it helps you on the test and you want to divide them up, be sure you put a slash in there and not something that looks like another 1. But if you need to divide them up, if I've got like 3 of them or so, and you want to make sure you've got the 2, the 5, use something big enough that I won't assume it's a 1.
Could you just leave a little space?
You could just leave a little space. Or put it underneath it. You could do that. There's not going to be a whole lot of room. You know, it won't be real wide, so if it's a big number, you might run out of space. Does anybody have any questions about numbers? Everybody feels comfortable? As comfortable as you can be? You don't understand it?
I mean, I know I can, but I just.
Okay. You understand that all numbers have the first 4 digits of 1111. That's just the way it is. Okay? Because whoever started this, whoever came up with the Ipsidic in the first place said, this is what it's going to be. That way the computer looks here and knows that what's following is a number. Because we've gone back to binary, we've got our 1, 2, 4, 8 number line. And it's divided up into 2 sections, so we start over on 1, 2, 4, 8. So if I ask you to give me a 6 in Ipsidic, you're going to automatically give me these 4. And then take these last 4 in the digit section. In that number line, how can I make the number 6? 4 plus 2, and you got to hold these places because there has to be 8. 1, 2, 3, 4, 5, 6, 7, 8. You got
the first one will automatically 1?
The first 4 are automatically 1s when you're doing numbers. Okay.
Can we do the last one again?
The last one again? Sure. All right. I asked you to do 25, but think about how many keys you had to hit to put that in the computer. You hit a 2 and you hit a 5. So each one of those become 8 bits. So we start for the 2 and we put in our 1111. And then these we use for the 2. So there we've got a 2.
Okay.
Okay? Then you start over for the 5. You've got your 4 ones. And 4 plus 1 is 5.
Okay, I understand.
Okay?
I got you.
Are you okay now?
I get it.
Everybody okay? All right.
So basically, when it's 2 numbers, you get split, right?
Uh-huh. 2 numbers split it. If it's 3 numbers, you split it into 3. And give me 8 times 3. Oh, hi. Well, I'm recording, but I never could find ITSC 1301. It's going. And I can see the other one in here, so can we link it later?
I'll see.
Okay, I mean, if you want to come up here and look at what's going on. I clicked all over. Let me stop it.
It's fine.
Oh, okay. I never could. I clicked everywhere. I called Terry, and he said, you go in and you click on that icon, and it tells you. I don't know. But I clicked on that, and I right clicked. And I don't remember what I had after that.
If you just open the camera, you must be recording to this machine. You must have your recording to your head. Recording is not through Tegra. That's what I'm seeing here. I'm seeing this is the other day.
This one's the other one.
Yeah. And if you just start recording in this window, yeah, that's the software that drives this. That's not Tegra at all.
So now I right click. What do I go to there?
You right click on what?
Isn't that Tegra?
Yes. So when you get on it, then you can go start recording. What you just hit was off of Tegra. But if you hit right on or double click on it,
Gotcha.
and then when you do that,
Okay.
like I can pick up what you're doing right now, so you can actually hear me. I go to test the audio, and then you can set up the video just right. It'll record everything.
Record that. Okay. Is there any way to get it off of here in the back?
Well, we can probably. I'll have to look at your file size. We can probably upload those files.
Okay.
We'll have to zip them and get them in there. That would take probably huge.
So at least they're not floating around.
No, we cannot know
They're
that.
here.
Yep. And you can see that it's working because it's going to pick up your volume. So if you wanted to jump straight into Tegra at this point, you click that and you hit record class and it kicks it off.
Okay. Could I come back in tomorrow and pick up finish up to here on that one? Can you add to?
You can have a session A, session B, however you're labeling.
Okay.
I
I mean,
So then actually,
thought I saw it as well.
Ipsy audio, we can catch it. Okay, so if I just click record a
click
class.
the record class.
Well,
And what's going to happen is it's going to start capturing what you want. And we'll see how it works. And the other solution might be still recording behind the scenes too, so we'll have both going at the same time. We'll see how it works. So we'll run them both parallel, see what happens.
Yeah, maybe we won't shut up this one.
Yeah, it might crash it.
Yeah, thank you.
Yeah.
All right. So, yes.
Will it ever go past 8? Or will it ever go past 16, 32, 64? It'll always be 1.
It'll always be 1248, 1248. Okay. Anything else? All right. So now you know how to do the numbers. In your packet, there is an Ipsodic alphabet. Does everybody find it? An Ipsodic alphabet.
Yeah, take that.
All right. Across the top are the zones, because we're still working with the first 4 bits a zone and the last 4 bits a digit. So across the top, the first zone is 1100. If we plug in this number line here, what is that number? 8 plus 4 is 12. What is this? 13. What is this?
14.
Okay, so the zones for the letters in Ipsidig are 12, 13, and 14. 4 bits with your ones and zeros. What have I done here?
It's just a sequence of 1 through 9.
Okay, I've put 1, 2, 3, 4, 5, 6, 7, 8, 9 into 4 bits. These are the digits. And then we start filling in the alphabets. A zone of 1100 and a digit of 0001 is the letter A, B, C, D, E, F, G, H, I. Then we go to the next column. J, K, L, M, N, O, P, Q, R. Now, how many letters are there in the alphabet?
6.
What is 3 times 9?
27.
So we've got an extra spot, don't we?
Yep.
For whatever reason, they decided to leave this first place blank. So there is no letter for 11110001. And then they skip down here, S, T, U, V, W, X, Y, Z. So you do 12, 13, and 14 across the top, 1 through 9 down the left side, and you start filling in the alphabet, leaving the first one on the last column blank. And you've got your alphabet. Now, using this alphabet, if I ask you to give me Ipsidig for the letter G, what are you going to do? What goes first?
The 111.
Okay, the zone. So where is a G? Right here. What is its zone? 1100. And what is the number?
0111.
You hit a G on the...
Changes. The zone is not 111.
No, because if it were 1111, it would think it's a number. So it looks here and it says, this is a letter of the alphabet.
So if it's a letter, right, it's going to be 2 1s in the front?
Oh, well, yeah. I mean, this one's got 3.
So basically from 2 to 3?
From 2 to 3, yeah. Just do 12, 13, and 14, 4 bits in binary, and you've got the zones.
All right, and all the numbers have 4 1s, right? No, the numbers
No,
have
4, you mean 4 bits?
Yeah, 4 1s.
Oh, yes, numbers, yes, at the beginning, yes. That's right. Is everybody with me on this? Do you see how we got that for the letter G? Sure. Let's do X. Where is X? It's over here, isn't it? So what is the zone? 1110. And, oh, I chose the same.
So you just go up and on.
For every letter. All right, what if I ask you to do this? Spell that in Ipsidig. Nobody say anything, just write it down.
Right, the numbers.
Write down the ones and zeros for math. Are you with me, Bruce?
Yeah, man.
You're just hanging on, huh?
Can we write it going down?
Nah.
Well, again, once we get to the test, there won't be room to write down. Just write it.
So when we take the test, I'll be, and then we'll be on my Scantron.
No, you can leave your Scantron at home Thursday.
Send them off.
This Thursday?
Uh-huh. If it wasn't Thursday, we'd have to go over something brand new. We could do octal.
We could just review them.
Sorry,
I'm going to give you 2 whole days to review. All right, so you're doing math. Here is M. 1101. Okay. And A, I'm going to have to go down because I'm running out of my camera view. So it's 11000001. And then T is right here. 100011. Is that how you meant writing them straight down?
No, I was meant like
You were doing this?
Yeah.
Okay, yeah.
No.
There won't be room for that. Here's the M, here's the A, and here's the T. Does everybody see that? I've had students put their name on the test and Ipsidic to get me back. If you do that, be sure you spell it correctly. Any questions? So now the computer can distinguish between what's a number and what's a letter. Everybody okay? All right. I forgot to bring the memory dumps. Would you and that polytechnic, the very first one, I think it's the second drawer. There's something in there. There are
Standard green bar.
yeah, but it's in a folder, and there's a bunch of math back there, binary, hexadecimal. They're just about halfway back in that filing cabinet.
Second floor down.
Second or third. I don't remember how many it has. Okay, now we just have established that this takes up a lot of room, doesn't it? And remember the other day when we went from binary to hexadecimal, why did we do that?
Smaller.
Okay, because the computer's not going to give you this when it tells you what's going on in memory, when it lets you know there's a problem. So what it does, it converts it to hex notation. So it takes what we have in Ipsidic and it converts it to hex. So we need our number line, 1248, 1248. What is 8 plus 4 plus 1?
13.
13. What is 13 in hex?
D.
D. What is this? 4. What is 4 in hex? That is hex notation. So instead of printing all these ones and zeros out, it would give you D4. Yes, yes. I'm sorry? Okay, sure. We take our Ipsidic. So you've given me, I asked you to put mat in Ipsidic. And you've given me this. To get hex notation, you take the number line 1248, 1248 over the zone and the digit, and you convert it to hex. So 8 plus 4 plus 1 is 13, right? And what is 13 in hex? A, B, C, D, 10, 11, 12, 13.
Okay.
So it's D. So we put a D there. What is this number?
What?
It's 4. And what is 4 in hex?
Going to
Okay, remember 0 through 9 looks
Oh, wow.
exactly the same.
yeah,
So it's a 4.
it's 4.
All right? Everybody with me so far?
Right.
Okay, let's do this one. 1, 2, 4, 8 plus 2, 4, 8. What is 8 plus 4?
0,
12. 12 is C. What is this number?
1,
What is 8 plus 4 plus 2?
E.
Okay, it would be 14, and 14 is E. What is this? All right. So you put this, you typed in MAT in the computer. It becomes this, the Ipsidic. And when it prints out what's going on, it'd be D4, C1, E3. All right, I'm going to pass this around. This is a memory dump. Over on the far left-hand side are just some addresses, some memory addresses. But look through that, and you'll see letter number, and that's all this hex notation. Let me see if we don't pass it back. Bring them back here since you're all the way to lonesome. Wow. I need these back, but just take a look at it. Now, as a programmer, as an operator, a computer operator, you might be expected to figure this out. What's the highlight mean? It's one word.
So like if you have to like code that out or whatever, how would you write that all out? It's in columns, would you print it out in columns?
Did you do that in the Word?
Would you do that like,
Okay, if you see a 4-0, that's a blank.
right?
So anything between a 4-0 and a 4-0 is a word. Or you see the numbers also. Remember in numbers, the first 4 bits are 1, 1, 1, 1. So if we're doing 6, it's 1, 1, 1, 1, 0, 1, 1, 0. To put that into hex notation, 1, 2, 4, 8, 1, 2, 4, 8. What is 8 plus 4 plus 2 plus 1?
F.
15, which is F. What is this? 6. So when you see an F, since all numbers have 1, 1, 1, 1 as the zone, every number in hex notation is going to be F. So F6, F3, if that's what you were doing. When we did this one, 25, it'd be F2, F5. And when it does the math, like what we were doing the last 2 days of class, it strips the zone. It strips this off so it can just use the number. It can't do math on this.
So where you see the letter number, you know that's the word.
Mhm.
With the two.
Yeah. When it's C, D, or E, remember 12, 13, and 14 are the zones for the letters. You know it's a letter of the alphabet. If it's F, it's a number. Okay.
And then 4 zeros is a space.
4 zeros. That. Okay. So it would. That's supposed to be a 0. You hit the space bar, that's what it does. Okay. And so when it converts it out, 1, 2, 4, 8, and then this is just 0. Okay. Let's do some more. I can tell y'all are excited about this.
Very much so.
Let's see. Okay, I give you that, or you've given me that. On the test, you're going to have, I'm going to ask you for Ibsidic. So I'll say, all right, give me the Ibsidic for a certain number. This is 59. And you're going to give me this. And then in the next section, it's going to say, all right, take what you just did in Ibsidic and convert it to hex notation. What you're going to do, 1, 2, 4, 8. 1, 2, 4, 8. 2, 4, 8. 1, 2, 4, 8. Just put the first 4 numbers from the number line over each of the 4 bits. Start way over there on the right-hand side. And then start converting to hex. 8 plus 4 plus 2 plus 1 is 15, which would be F. 4 plus 1?
5. F. 9.
Or we could just automatically go ahead and put down the F and the number for each number.
If it's a number, it's F, this number, F, that number. All right, now, if I ask you to do a C, you're going to give me that, right? This is the zone, 1, 1, 0, 0. 2 plus 1 is 3. Okay? Give me the hex notation for that. What's the first thing you're going to do?
12.
Put the number line.
Oh.
You put it in your head, didn't you?
That's why I got a headache. It's too many numbers.
8 plus 4
12.
is 12, and 12 is what?
3.
There's your hex notation. You're ready for the test? Yeah, and you're over there moaning about it being Thursday. You can do it right now, huh?
Yeah. Hey, but the my hold on that stuff on the radio we did before. So
No, you're going to study between now and Thursday.
So you had a hex symbol or a decimal, right?
I'm sorry?
Thursday.
Thursday?
Over everything, right?
You're going to have a test over everything
Yeah.
Thursday. Yeah. Yeah, binary, hexadecimal, Ibsidic, hex notation, and one more thing. Is everybody okay here? No?
No, it's get confused.
Okay.
I don't get the 59.
Okay. 59. How many keys did you have to hit to put this number in the keyboard? You had to hit a 5, and you had to hit a 9, right? So this 5 becomes 8 bits, and this 5 becomes 8 bits. So we're going to take the 5 first. The first 4 are always 1, 1, 1, 1 on numbers. So then you take the last 4 bits and make this number. 4 plus 1 is 5, right? All right, so now we've got to do the same thing to 9. 1, 1, 1, 1, that's the given. And then what is 8 plus 1? None, okay? And then when you convert it to hex notation, just take your number line. 8 plus 4 plus 2 plus 1 is 15. 15 in hex is F. 5 in hex is 5. And then F9. Okay? Everybody else okay? Okay. That's for the bigger computers. What about this and smaller?
We ain't worried about it.
You're not? But many of us, that's the only thing we'll ever use. When you go in to get your grades or when you register, you're accessing a mainframe. But when you sit down to do your labs, you're working on one of these. Some of you one day may have a job in a place like McLean's or Scott and White or, some really big company, and they're going to be working with mainframes. Maybe even supercomputers, depending on where you get that job. But at home, we're going to have this. So let's understand what it does. And my pens keep running out of ink. Guess I'm doing too much writing.
I've got one.
No, I had 3, so that one's good. Thank you. Desktops and smaller use a coding scheme called Ascii, which stands for American Standard Code for Information Interchange. Again, you just need to remember ASCII. It also uses an 8-bit code. One of the main differences is it doesn't divide it up into a zone and a digit. It just strings out the 8 bits. So if we're using our number line, it's 1, 2, 4, 8, 16, 32, 64, and 128. In ASCII, all numbers have the first 4 bits equal to 0, 0, 1, 1. All of them. So that's similar to Ipsodic, and that the first 4 there are 1, 1, 1, 1. It's just they're using a different, it's 0, 0, 1, 1. If you want to look at it as a zone, if that helps you, then do that. So again, if I ask you to give me 7 in ASCII, what are you going to do right here automatically?
0,
0, 0, 1, 1. What are you going to do here?
7, 0, 1, 1.
You do the same thing there you did in Ipsodic. Just convert 7 to binary. Okay, here that's the given. All numbers, the first 4 bits are 0, 0, 1, 1. So we automatically put this here. And then the last 4 bits, we don't need an 8, but 4 plus 2 plus 1 is equal to 7, right?
So, in ASCII, it's always going to start with 0, 1, 1 instead of
0, 0, 1, 1. All numbers.
All numbers are going to start with 0, 0, 1, 1.
Mhm.
In ASCII.
In ASCII.
Okay.
Okay? In Ipsodic, they start with 1, 1, 1, 1.
Okay.
You're going to get it. All right, what about the number 13?
0, 0.
How many keys did you have to hit?
0, 0.
So we've got to do 0, 0, 1, 1, and then we've got to do the number 1. 0, 0, 0, 1. We've got to do the same thing for 3.
0, 0, 1, 1.
Okay.
Okay? So again, we divided it down the middle, and we did 8 bits for 1, 8 bits for 3.
So what is it? So what is all those numbers coming in? For ASCII. It's over the zeros of the 8 zeros at the top.
Okay, where are they coming in?
I mean, we have where do you factor in that? Because if you got 0, what do they represent?
All of these here. This right here, the computer looks at it and it says, okay, what follows is a number. Because if everything in there is a 1 and a 0,
I just think it's
okay, it's got to have a way to distinguish between alphabetic characters and numeric characters, and this is how it does it. And the 1, 1, 1, 1, or the 3 zones that are at the top of the Ipsodic alphabet, is how it distinguishes from one to the other.
Gotcha.
Okay? Is everybody okay here? on numbers. Okay. For letters of the alphabet, there's not another chart. All letters, the first 3 bits equals 0, 1, 0. All letters. All letters. Okay. Thank you. For A through Z, they all begin with 0, 1, 0. So if I ask you to do the letter A in Ascii, you're going to automatically give me that. And then let me say this, and then I'll explain it. The other 5 bits are going to be used to turn on the number that corresponds to the letter's placement in the alphabet. What letter of the alphabet is A? It's the first. So we're going to use those last 5 bits to make it a 1. 0, 0, 0, 0, 1. That's the letter A in Ascii. This is a given. These last 5 are there to equal the letter of the alphabet, the number that corresponds. So if you have to, write A through Z and 1 through 26, or 27, 26, down beside it.
So all of them 0, 1, 0?
Always. On letters, the first 3 bits, the 128, the 64, and the 32 will always be 0, 1, 0.
So what if it was a Z?
If it was a Z. All right, what letter of the alphabet is Z? It's the 26th letter of the alphabet. So you're going to give me this automatically. So in that number line, what plus what plus what equals 26? Okay, yeah. So 16 plus 8 plus 2, right? 8 and 2 is 10, plus 16 is 26. That's Z. Is everybody with me?
Yes.
You know, if, like I said, if you have to write it down, use your fingers, whatever. A, B, C, D, E.
0.
Do I know?
27.
Huh?
It's 27. You said 27?
Oh, yes. Thank you. Anybody have any questions?
So we can write both of our number charts on.
Oh, we can't write number charts on the test?
Yeah, once you get the test, you can write anything you want on it,
Oh.
as long as your book is closed and your mind is open.
We can use this one.
You can use the addition and subtraction chart. Yes, sir. You may use that. No. The one that has all the hex?
Yeah, the alphabet.
No.
What do you remember that?
12, 13, 14 across the top, 1 through 9 down the side, and just ABC, leaving the 3rd column at the top. Everybody take a deep breath. Y'all will be fine. You'll be just fine. Trust me. All right, now hang on. Stop.